All right. What are we going to do today? I actually wanted to talk about something I just want to get off my chest because actually I wanted to get this out for turning it into an article maybe later on. One thing that's interesting, right, is like to do. Let me make a tea and then I'll start yapping. So the thing I wanted to yap about is like to do this kind of like AI programming stuff, right? You kind of need to have these kind of like staff engineer, like architecture astronaut kind of skills, right? Like you need to assemble a lot of fairly complex technology in ways that often require like kind of human collaboration skills, right? Like you need to know what kind of documents to write to make an LLM write front end code for a certain type of back end code, for example, right? Like you get a sense of like planning documents and specs, like all of these words that agentic programmers or whatever are talking about, right? Like organizing things, coordination, trees, all of those are fairly advanced skills as far as software engineering. You need to work in a company on a team to kind of get to experience these things. If you work on your own, you don't need specs often, you don't need like a plan, you don't need a code review. All of those things are senior engineer skills, right? Or even staff engineer skills. And even technology wise, the fact that you can, and this is something that I'll maybe try to do today. I don't know. I'm going to do something experimental. The more you know about fundamentals of technology and the fundamental limits of it, knowing what's really hard versus what's really easy for an LLM to do, um, the more, um, well, the better you get at vibe coding, right? It's like if you know what WebSockets are, if you know what React is, if you know what Redux is, if you know what I don't know, a certain pattern of distributing WebSockets in React is, then you can vibe something in 3 words. If you don't know that, you can probably spend like $100 just like doing some fuck shit and then ending with a huge code base. Um, so you need both these understandings of how to coordinate a big project, because even if you only use a single agent, for example, like I do, you still need to think about context window, passing things over. How do I resume from zero? Like you still need coordination skills, even if you only use one agent, right? You also need a certain type of document that these models have been trained upon, or a certain type of document that has been found out works well. So, for example, like an open API spec is something that works really well to communicate what an API is without having to inhale code, for example, right? So, as a good LLM programmer, you know that the prompt "make an open API spec" is like a pretty good one, and that's like kind of the knowledge that gets shared. The knowledge gets shared on Twitter. Is like, hey, you should use this format to do a spec, and you should use easy, and it looks kind of like funny to people who have learned that skill organically, where they're like, yeah, but people are just like cargo culting us to like use this spec and use this spec, and they're like talking about all of this stuff. I know from my experience as a super senior developer what it actually means, and it's like programming, blah blah blah, right? But the thing is that if you're a junior developer today, this is how you program. What you're doing is what took us years, if not decades, to understand and figure out. You do it at breakfast, right? And to do three coding projects in a day, even if you don't know what you're doing, right? Like even if you're just like pasting prompts in and being like, yeah, whatever, blah, 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 superpowers, spec driven design, TDD, whatever, even if you don't know what these words mean, you are actually doing it. And if you do something long enough, because we were all born not knowing how to do anything, you'll get really good at it. Here amount of doing and being curious and figuring out what works and what doesn't. Um, and what's really interesting here is, and something as I've I've like kind of looked back a little bit about the way that I build projects today versus what I did before LLMs or before getting really good at LLMs, before the models got so good. The complexity architecturally of what I don't even think about these days, and I hope I'll be able to show that on stream. When I'm on stream, I'm not sharp. Takes me out of it. The complexity of the stuff I built is like I don't think I could maybe dream of it and have like a vague idea of how things could fit together. But now I build it every day. So I do actually figure out, oh, this actually doesn't work. Or like, oh, this works really well. So what I'm figuring out every day is like 4 times a day, I'm going to try out a design pattern, for example, that I was curious about. I tried before because it would have been just so much effort saying like, hey, I want to connect my, my like embedded thing over a WebSocket to React and then like kind of have it send back some JavaScript stuff to display something on the display. It was like, yeah, this stuff you can dream up in the evening, but like you're never going to do it. Or if you do it, it's like, a real project that you would go to conferences to and talk about like that, right? But now I do that literally on the side. And so I'm going to try to show something a little bit. My tea has finished, so I'm going to come right back. All right, we're back. So one of the things I've been playing with is like Tree Sitter, right? So I have all these technologies that I've always been curious about, always like dealing with ASDs and compilers and all of that stuff, right? And then that stuff was complicated in the day. It's like not pleasant code to write, and you have to think really hard. And right, even though I have an idea, for example, the thing that I'm building right now is like using Tree Sitter to sanitize YAML, right? And so this is something that's like almost finished now. So it's probably not that interesting to look at. Dude, I did this at midnight. I was just like, yeah, wouldn't it be cool to have like Tree Sitter sanitize YAML? And I prompted it, and like something like this came out. It's not exactly this, because then I had to go back and be like, hey, the model kind of did something with Tree Sitter, but it also like faked a lot of stuff with um it sorry, I was distracted. It like faked a lot of stuff with like string wrapping, and then I looked at why did it do this, because I know that GPT-5.4 is pretty good, so I had to understand, well, there's certain things like this Tree Sitter thing is like pretty lenient, so actually your idea doesn't work all that well because it does accept a certain amount of things, right? Like this thing here, I think is an error of it. And however, oh, it did parse it as an error, because this is something that it would like, see, when I do it twice, it actually doesn't parse it, as it says no error. So I started noticing, well, okay, the quality of the Tree Sitter YAML grammar is not that great. So that's why the model decided these cases anyway using regex. All right. So I was like, yeah, there's sharp edges, and I would have never experienced those if I would have always had the idea of like building a project like this. But if I start looking at the code, right, and this has gone through a bunch of GPT now, so it is already kind of pretty well organized, and has a mix of like YAML Tree Sitter parsing and then YAML not parsing and stuff like that. So maybe a good project is well, it is showing the sanitized version, right? But like the sheer effort I would have needed to build a UI that actually also even doesn't look half that bad, there's no way. But having this UI really allows me to like start exploring different conditions that I was thinking about, right? Like, oh, if I do, oh, look at that, it corrects it. Like, this is amazing, right? Um, I would never have really had the effort of, I would never really have gotten to the point where I would encounter these issues, which are hard to solve because they are hard to solve for an LLM by the simple virtue of them being not solved correctly, right? So it's either a skill issue, I prompted the LLM wrong, or it's like, well, the LLM doesn't know how to do it. So every time something fails, I'm like, oh, this is great, right? Like this is where the engineering is. This is where my value add as a human is that I found something the LLM sucks at. Great. Right. And so I've gone through when GPT-5 came out last year. It started doing things where I was like, man, this is a really good design. Like I didn't think of this. This is, just like gut feeling wise, I was like, man, this is good. But then it would do like all kinds of nonsense. So I was like, yeah, sometimes you roll the dice and you get something good. That's over, right? Like in terms of architecture, definitely since 5.4, I'm like, I'm not going to even think about architecture. I'm just going to ask the model about architecture. Then maybe I'll tweak like one or two things, and I'll be like, go ahead. I'm not even going to try to architect my code at a granular module level. I have to think at the bigger picture now, which is like, how is this going to evolve over time? Which guardrails do I need to put in? Which is really, really staff level kind of thinking, right? Thinking, where is this code base going to be in 2 years? Except here, 2 years means in like 5 context windows or whatever. So, for example, the rule spec stuff is the last thing I prompted. And I think I even have the ticket for it. Anyway, where I was going with this before I get into the coding is junior developers these days, like teenagers, really do that. Like they're going to experience these skills that took me a decade, um, or um, or two to learn. You get to experience them in like turbo mode, and like my understanding of what I do now and stuff like that is I read a lot of books and I'm really into books, but dude, like I didn't teenager time to read books, right? I would maybe for a long time until LLMs came out, I would like maybe do 2 hours in the morning every couple of days to learn some machine learning, Bayesian stuff. And then I would have my normal adult life come in and I would like forget everything and I'd do like maybe start a Coursera and then I would get nowhere. Um, if you are a teenager or a young person, you have way too much time and you don't need to spend a lot of money. Um, you're going to experience these large scale software building um, multiple times a day. Like, what does that fucking mean? It's like I was always like, senior developers, you're like saying we don't need junior developers anymore. It's like you have no idea what's going to happen to you. The same way of me being the first generation that like grew up with a computer kind of, where my parents were pretty strict about it, so I wrote on paper, but um, what I could write, like a program every day, maybe. Like I would write a game on the weekend in BASIC. It was like a shitty game. I had no idea what I was doing. Took me like a month to build Hangman and Turbo Pascal. But that's how you learn, right? It's like I just copied stuff out of books and I was like, yeah, la, la, and then it failed. And I was like, man, the book doesn't tell me how to fix this. I guess I have to figure it out. Then I wanted to piss my teachers off, so I would write like viruses. Um, assembly, right? And it's that's how I think I became like a decent programmer is and then when I hit the workforce, the older guys, their knowledge of programming was like, well, we have like a workstation at work. At home, I don't have a computer, or maybe I can do some, and then software was this like thing that they wouldn't do, right? Like software was work. And for me, software was like writing a new program was like kind of, by age 20, I've probably written like, I don't know, 300 programs. at this point, but I have like, hey, I've got time today. I'm going to build like a DNS server. And so by the time I hit the workforce, I'm like, like I'm ready for web development at a really large scale because I've been doing it for a while now, right? I've been doing it with my friends. We play like catch the flag stuff. So I'm kind of ready to take on some pretty big challenges. I've been like, um, the same way the Arduino generation has been like a complete shift in how embedded software is written, right? Like, because before embedded software was like, you've got a really expensive compiler that's total garbage, and you've got data sheets that are also kind of garbage, and you have to figure all of this stuff out, and no one helps you, and like everybody's old and hates young people, and came out, all the kids suddenly could play with the Arduino at home, and it was easy to say like, you don't really know embedded, you're just like using a library that toggles the pins. And now you look at what these people are doing, and it's like the most insane Rust OS. It's and so the same thing I think wherever software is going with these things is that um, kids are going to figure out the hard stuff pretty quickly. And then they're going to do the hard stuff multiple times a day while you're still stuck like arguing about a REST API or whatever. Like REST APIs, like I like they don't literally don't matter anymore. UIs, dashboards literally don't matter anymore. I can make like 20 a second. Um, and so that was the thought I wanted to give off is like we like the generation that currently says like, yeah, we don't need junior developers right now has absolutely no idea what's coming. I have no idea what's coming. Like I'm also an old fart. So um so anyway, when I look at GPU code, it's like almost too clever. Not clever, it's like too too good. It like freaks me out a little bit where I'm like, oh, it's a shit ton of file. And I look into every file. I'm like, it's kind of nice, man. I'm like, you found like a good way of naming the file. Like this is all pretty nice. Like maybe you write a little bit too many tests for my taste, but then you also seem to be able to delete them. Um, and there's barely any like there's this kind of stuff, right? Where you're like, is this duplicated or not? It's like flagged by my I don't think this warrants the duplication as far as I'm concerned. And I also know that it's going to deduplicate it anyway, especially if I tell it to look for duplicated code. So I look like, man, like duplicate keys, why does it need its own file? And then I look at it and I'm like, oh yeah, this is actually complex. Like all of this complexity actually kind of makes sense, right? Like there's GPT-5.4 has this way of, at least at this like program level almost, of just building perfect programs. What it doesn't necessarily, even though it's like scaringly good, is like build large scale architecture, think about long term longevity of the code base, which I'm sure will be something that's going to be addressed. And I also still think that thinking about code bases is something short-sighted. It's like a little moment in time where we still think about looking at this stuff. The only reading of code I do is kind of like, what's this file? And then if I see like a 4,000 line file that like Opus has created, I'm like, okay, this needs to go. Or I'll be like, I'd be like, hey, why is there a file called indentation? And I'm like, oh yeah, because indentation is actually a complicated problem in the context of what I do. Yapping. What I'm going to do now is I want to add JSON tree sitter stuff. Oh, and what I'm doing now is this is the shit I'm reading now, where I'm like, hey, there's some really complex problems out there. Like, what is distributed storage? Still like kind of an unsolved, uh, in many ways unsolvable, right? Um, and so now I'm at the level like, hey, why not rewrite Kubernetes in simpler? Because I can just do this, right? How does Kubernetes work? Add pseudocode examples. I want to build a solid but single user version of it, right? Like this is something I would like to have, is like kind of like Kubernetes like building block. I call it sampling now. I'm going to sample Kubernetes because obviously it has been trained on Kubernetes source code. So I'm like kind of sampling it by the simple virtue of like saying its name. Um, but this is 5.8. Actually, I'll show it like I'll show it. Um, so I'm gonna let this run in the background. Right? Like I have an hey, wouldn't it be nice to have like a single node? Maybe I don't even know what's going to come out because I don't know Kubernetes that well. But you know, I don't need networking aspect of Kubernetes. I maybe don't need the whole like crazy storage stuff. I just want something where multi publish things, identity, have versioning, and like kind of subscribe to an API to get updates, right? Which is a concept. That's the level I think at now, is I'm like, hey, I want something that's distributed where I can like listen to changes on resources and they're versioned and have like a global ID, and I can kind of coordinate over it. The other thing that I wanted to do that's maybe like a little bit more pedestrian for the, I mean, not pedestrian, but like a little bit more simple for the stream. Maybe I should just write the diversions. So 5.4, I think, is really good at clarifying my thinking. Obviously, there's going to be some psychosis, sycophancy in there, right? Where I think it's well explained because it's just like sending my words back to me. But 5.4 genuinely sometimes throws stuff, or like often throws stuff at me where I'm like, I never thought of that. That is really interesting. I click on the link. I see that there's a whole paper that has been related to it. And there's prompting ways, like for example, a skill, and I think this is the kind of skill that developing, is that this way, which is how I prompted as a senior developer. But you can prompt it this way. But first, explain the fundamentals of it, including how this was discussed in the 70s, 80s, and the kind of fundamental research that is being done today. Because what matters is what I'm connecting conceptually, right? Like Kubernetes is just an instance of trying to solve a problem. It's a problem. It's solving a problem that I don't really have, which is A, it was written by humans for, which now is not the case anymore. And it was written for organizations and like huge teams, which is also not necessarily anymore. But it does solve the problem of a distributed control plane, right? With persistence, with like events, with an API, with like security, with like overlay networking. And so all of these concepts, overlay networking, if I need it in my app, Kubernetes is just like a shortcut for it, right? Like the same way, that's what we use frameworks for, is like solving hard problems. The problem is hard. The technology isn't. Kubernetes is not hard per se. The problem that Kubernetes tries to solve is hard. And because it's hard, it just, I don't know how to say it. The reason like LLMs can kind of solve it is that the problem has been solved before, and that's what they're going to go to. But a lot of problems before, because people do math and do computer science, so see how it's starting to look at, this time it found Raft, right? And here Raft, I'm pretty sure. It just stays at the like GitHub enterprise kind of Kubernetes level, really gets to the fundamentals of it. So we'll stay at this like surface level kind of cargo cult enterprise. If, however, you add this as a prompt, then it's going to get to the real shit. And maybe I'll see like, hey, maybe I don't even need Kubernetes. Maybe what I'm actually trying to get at is, and so suddenly I find these articles that are, because the LLM is pretty good at like, it knows all these technologies, right? I don't. Um, and because it knows all of these technologies, it's able through pattern matching, so something that is within the realm LM, through pattern matching to find an elegant, simple solution to it. Because it will work backwards. It will say like, hey, Kubernetes is trying to solve this problem. It has been solved or attempted to be solved or has been implemented in 18 different ways before. There is a common pattern to all of these 18 implementations. And I created, because I've worked backwards on the tree of abstraction, I'm doing like a lot of gestures here. So I have all these implementations that look immensely because thousands of people have worked on them, but they're all trying to solve a problem. They're using smaller blocks, right? Like, so Kubernetes, at least the K8s, the 8 distribution, is using etcd with like a Raft um, leader election. I don't gossip. I don't know what the name is. I used to know that stuff. And then I work backwards. And then ultimately, the problem I'm trying to solve for my application right now is basically persistence of globally named objects across heterogeneous networks, right? And because ultimately, what I want to do, just to explain, I have this little guy here. I've got my computer. I've got like lights out there. I can send JavaScript to my light, and I want to address this guy specifically, who is an instance of this class, to send this piece of code specifically that is an instance of a larger piece of code that is the code on this. And so I want, when this thing turns on, even if I have reflashed the firmware or whatever, that it fetches its code and starts executing it. The same for my lights. And then I also want that this guy and the lights, depending on which network they're on, still communicate with each other, right? So if I take this device with me and I want when it turns on and disconnects to the warehouse to still control my lights at home with the software that I wrote. And trying to solve that is, I could do it ad hoc. I could say like, I need to write, think my way through it, and then probably build something that's like working for my case, but the next project I do, I won't necessarily be able to reuse it. Or I could figure out the fundamental problem of it, which probably less time than than coding, hacking my way through something that's probably not right theoretically, because I'll encounter the complexity of trying to solve a problem the wrong way. Um, However, if I work my way backwards and I find all these papers that are like, hey man, there's so much sycophancy today, because it's reusing shit from my previous conversations, but off memory. Maybe I should do that. Like, fuck it. Settings, memory. Where is it? Personalization, memory, about you, memory, reference, saved memory, reference, chat history, goodbye. I think that was what it was. Where I was fucking it up so much. I don't know why I turned it on recently. Anyway, hopefully that will make it better. And actually, let's see if that actually, because I don't trust this memory setting. Anyway, so I don't know if I'm like getting the idea across here of like what I think, how my skills have evolved is that I go straight to this shit now. I'm just like, hey, this is fun. This is actually why I like computers. Is like not the computer itself, is like actually this stuff. So maybe I like math more than I do computers. But now suddenly I'm like, these words are the one that are interesting, right? Control plane and worker nodes. And then I get the pseudocode. So here I know that pods and deployment, they're like clearly Kubernetes names. But I have control plane and worker nodes, right? So one thing I can do, and I'm going to use here, and a friend told me, like, it's funny how much programming you actually do in the browser. Like, it seems like you're almost entirely programming in the browser. So what I'm going to do here is basically take these two concepts. I should have looked at them a little bit more, and I'm pretty sure it will like figure out this is Kubernetes. because of the words, but I would erase the Kubernetes from the words. Um, see Kate's reconciliation control plane. But even that has value, right? Like I've done this before, so I'm not all that interested in it. So one thing I could do maybe is like go back here and then say output the code so that it's really separate from Kate's, so that I can reuse it. See, one ancestor is the Blackboard architecture. This might come from memory and might be. I think this is sycophancy, but it's sycophancy with sources, so it's not that. This is the first article that it found. See, ISIS, I had never heard. So that might be something that was surfaced in a previous conversation. This is new to me. This looks very interesting. So what I do at this point is like, I'm going to save this, not this one. Oh man, did it close it? I'm going to save this guy, and then I'm going to go to my tablet and I'm just going to upload it. And then tomorrow, maybe I'll read it or something. But so this is kind of the real value of what I do, right? Is like understanding the fundamentals, because once I understand the fundamental, did I actually prompt it to output the code so it's really separate from Rails so that I can reuse it? I want to get at the fundamentals, because then I can start doing this, right? I can start playing with it. And this, I never really realized that it's play, right? Like play being one of the most important things for learning. Fucking with shit, basically. And a designer that I met on recently, like turned me on to it. It's like, yeah, what we're doing is playing, right? And so this is looking at the Raft stuff. This being theoretical, I won't be able to oh yeah, nice. This is the deployment thing, right? So you can see that how it kind of works. Yeah, this is cool. I'm pretty sure this is correct at this point. Like I think models are good enough that you can throw this kind of shit at them. And also you suddenly realize like, dude, is this what Kubernetes is doing? Like, is this all there is to it? Which kind of is the case, right? And then if you look at the actual code, where you're just like, oh, is it just lying to me? No, the reconcile algorithm is here, right? And then this looks, it's a little bit more because it's actually in a hook, which is pretty funny. But the code for this, most of this is visuals, and then you're like, hey, this is the reconcile loop of basically Kubernetes. Obviously, there's the hard part of like a call. If you look at the source code of the Raft protocol or its mathematical formulation, well, people have tried to make it simpler, but that's where we got to, and then people still find bugs in it, so some stuff is just genuinely hard, and it's usually math. It's usually math or like stuff in the physical world, or it's communicating with humans. So this is great because then I'm like, well, I don't need all the other stuff from Kubernetes. This is enough for what I do, right? And so at this point, what I can do is, I mean, in this case, I would go back to maybe to GPT-5. I'm gonna take this code, right? And then I'm gonna put it into Kate. No, I'm just gonna call it Kate's demo. Yeah, nah, let's gonna call it like control pod deployment demo. I mean, it doesn't really matter. It's actually not MD, huh? Deployment MD to pod temp pod deployment dot gsx. Yeah, whatever. Then I'm gonna go into. I'm gonna make like what I call like the play projects. I used to have them in a big repo. Now I do individual repos for it. I don't know how to deal with this play software. But we are the 13. I'm going to do pod deployment demo, right? And so I'm going to go into my pod deployment demo. I'm going to initialize the Git. Then I'm going to open Codex and I'm going to say create a new doc manager ticket to implement a pod deployment demo. Import the file temp deployment tsx into the ticket with doc manager import file dash dash file temp pod deployment. I should make a skill out of this. Or no, ticket and read it, then create an implementation design document too. And now comes the real part, right? Move the pods plus algorithms to a Go backend and just send visualization info to the front end over WebSocket so that we can keep the visualization but have the code in Go. This is, see, my prompting skills are not sharp because this is about an infinity longer than what I would do normally. So it's really interesting to see. I think I would be able to put this in 3 words. Let me see. I'm going to see if I can figure out the that I would normally do. So I'm going to delete all of this. I'm going to say create a doc. Shut up. You can already tell I'm dropping stuff. So what I changed, just to remind you, this was my previous prompt. So this is just garbage that I should put in a skill. I added analyze, which I don't know how much it matters. I haven't really benchmarked that. I didn't want it to move straight to implementation. So this was a mistake, right? Like I think using implementation is a mistake. I analyze. And then because I was not talking, I was able to realize, hey, how do the workers actually work on the back end? When I was talking, I like didn't think of it. I'm like, what is a worker, right? Move the pods algorithms to a Go backend. Like here, I was like, move pods and reconciliation algorithm, workers as Go routines, plus the question, how do they even communicate? So you can tell the difference in thinking effort that happened. And I'm really glad I'm able to capture that while I'm streaming. I really need to shut up because this is going to be pretty effective and I'm going to be in the loop. There's a good chance that I would only have realized that I do nonsense way later. So I'm really glad I'm able to, that I've caught myself 1 or 2 streams ago where I was like having so much trouble on stream always. To now notice, I know what it's not because I'm unlucky. It's because literally lack of skills, right? Talking about it makes me less good. So after that, usually what I do is like, you know, this is running. I don't need to watch over this. I would go back here and I'd be like, you know, let me play some more. Mess around with this. Um, or I would read like a previous document. And if I want 6 here, then this is going to take a little bit. There's going to be the scheduler is going to create 3 requests, and then they're going to be fulfilled. I'm going to go through 3. The scheduler goes over it, starts to kill them, and I don't know how canceling actually works. Create list drift detected. Who says drift detected? Chaos. All right, chaos mode. That's funny. I didn't think that a chaos mode would be good. This is actually pretty. I don't know if it really does too much chaos. Oh, actually, it like killed itself completely. That's funny. Chaos killed the process. Now a new process comes in. This is great. So this is a cool thing, but it doesn't absolve me of like understanding the algorithm, right? So I can also go back to the other things that I was doing. First explain the fun. This guy has been going, see how much is. See how much more general this is? Because this is literally what we just had, but oriented for pods and deployments, right? So we had these different layer abstractions, like you have Kate, like the real one, where the reconciliation algorithm is buried in like 18 different layers and config files and stuff and whatever. Like it's going to be really hard to find. I don't even find a loop as such. But see how it's able to find the rock, and then this I can apply to everything, right? Like this is a really, really powerful pattern for everything that's agents. If you look at it, right? The agent looks at the world, it sees which it wants to have. So the agent has like something that it wants to do. It looks at the world, it compares it, then it plans for the difference and executes the action. It's like almost so simple that you're like, what the fuck? Like, of course, this is how it works, right? But that's not. And there's some subtleties. Like, I don't know what summarizes. I don't know what this, I don't know why this is here. Is this just folding back? I'm not sure about this. This is where I would again shut up, pull out the papers, being like, what the fuck is summarize? Obviously, I would also ask the model, but I'm going to not ask the model right away usually. That's why I really like having the as an in between. So by the tablet, I mean this guy here. So most is actually spent on this device, not at the computer at all these days, which is also kind of. And I would try to read through all of this because probably the summarize lined somewhere more precisely. No, it's not. And I'm like, is this just a hallucination? I found that GPT likes to create up words like this. I don't know if anybody else has noticed that. It will like do a lot of jargony gibberish. Like it will do a lot of jargon that's like correct. Will like introduce some more jargon that's like looks related, but hasn't been like I can't find the source of them. Usually I'm able to find the source of these kinds of words. Here I'm like, the fuck? So I mean this is interesting. Why did you use summarize actual in the first code example? And I'm doing, see, I'm tired because usually I would leave that out. The reason I put the backticks, like I'm not tired, is because I'm speaking. I put the backticks to just say like, look, it's code. Actually, what I'm referring to, so I don't need to give information about what I'm referring to. Where does it come from, and did actual get updated by execute actions? Because this is the kind of stuff that I noticed. Is like, well, summarize actual comes from here. Nothing has been changed. So why do I need to write this back? And the actions probably change actual. So I'll do this. Maybe I'll turn off the thinking. I don't really know how the context window works in here. Okay, but here status reflects the world before the action's finished. And I suspect that that is interesting. I mean, it's going to loop afterwards, right? But uh-huh. See, I think a really important part, or not. It might be that I'm going around a rabbit hole of hallucination. So that's why I'm going to do this. So this is like I'm going down a rabbit hole where I'm not an expert. I have no idea if this is even true or not. There's a reasonable chance that it's true, but also I've gone down rabbit holes with 5.4 where it will start with a lot of papers and then it will do this, right? Where there's no sources. And then you kind of spiral and then you find weird papers that actually good papers, right? So so you have to turn this on, and then you have this like Chandri Lamport stuff and CRDTs. This points me back to like, okay, we're back in territory. We're not like in cuckoo crank territory. So let's go see. Let's go see what our agent is doing. Where were we? There we no. Oh yeah, there we are. Created local doc deployment 001 and validated cleanly. And it uploaded all of this. So I can show you what I do now. Let me go here and then let me go to SSH. And then I'm going to turn on my stream. There we go. No, 10 admin password. And here's my tablet. So what I do now is go here and go to today and the ticket appear. Hopefully. Did it do it? Oh, I forgot to prompt it, huh? I fucked up the prompting. Okay. I am prompting because I hope that it's written correctly, because usually I ask it to write it for an intern. So I mean, this is going to be a good occasion to see the difference. So I'm gonna just add this, create a new that is very detailed. Yeah, the first one might be too terse. So I'm gonna put this in. And in the meantime, we can still, oh, it's still uploading it. So there we go, upload bundle. It's done. Upload the document first, then do the new one. I was too eager. Man, I'm at set already. I guess it's, how many days do I have? 18. I do use more tokens than I thought, huh? It was just like their fuck shit in the last couple of weeks. I've significantly, I mean, because I do open source all day, I do burn a lot of codecs because I have so many funny little ideas. So did this upload? The previous attempt left the remote ticket folder in place, but apparently, yeah, because we can see the folder appearing, but there's nothing in it yet. So did it upload it again? There we go. And so now I'm going to shut up a tiny little bit and I'm going to read this thing. And people say that GPT-5 is yappy. I don't think this is yappy at all. So anyway, I'm going to think a little bit. Hopefully, I mean it's on video afterwards if you do actually want to follow along. What I do is like I put color red on, and then I'll go over and just like annotates that I have, right? Like this is really about my understanding. It's not about verifying what the model did or whatever. It probably did a better job than me. It's about me asking questions. Do I understand this? What sticks out to me? Why is something the way it is? Um, Before, maybe with 5.2 is when it changed. With 5, I don't think I was using this technique that much already. But with 5.2, I'd be like, yeah, I'd better be careful. There's going to be like some weird shit in there. When I use Opus, I definitely double check. There's always some nonsense in there. With 5.4, I'm like, oh, teach me, master, which is I love it. But it is, this disconcerting at first. Half my annotations, which is how I was as a kid as well. Except here is no one's going to take it bad. Because I used to get detention quite a bit because I would always ask questions too much, and people like make fun of them. I never understood that. It's like if I'm asking questions because I don't know, and obviously I have respect for you because you probably know. I think that you know more than me, and then people get upset, and I'm like, "What did I do wrong?" And then I think I'm of a little shit, and then I don't know. It still happens as an adult, right? But so you can. I'm introspecting a little bit. Um, I'm still having a dialogue in my head. I think I don't know what state my brain is in. I definitely like a verbal dialogue, even though I write it down. It's a very interesting thing. It's like writing a diary, but like I'm definitely not thinking in words right now. I am thinking in like a linguistic kind of next token prediction kind of way. Here, the fact that all of this is usually okay, why and stuff like that. I think I want to move my hand and I'm bored. I'm like fidgeting more so than I'm doing real like I do writing and thinking as well, but here I think it's just some fidgeting. So this is interesting, right? Like if you look at this, read the desired state, read the actual state, detect the drift, create or delete pods, sleep until the next resync. If we go to um, this guy here, right? This didn't know the code, but if you look at this, read the desired state, read the actual state, detect the drift, create or delete the pods, sleep until the next resync, desired actual diff, right? Actions. So this is an instance of the algorithm. It's not the generic. So you could be misled, and the LLM is going to be misled to say that this only applies to pods. There's no bigger concept behind it that I could reuse for storage. I mean, I know that it's clever enough to figure out that storage is the same thing. And in some ways, GPT-5.4 does recognize that this pattern exists or has been trained enough on it or something. Or like they mean the same thing, obviously. But previous models would be as clear, because what you can see is like if I write things this way, right? And then like the transition here, this is something a small model can do because it just replaces object with pod, and then it instead of plan, or it implements plan as a scheduler. Very easy to do, right? Model. So by finding the generic concepts, you actually reduce the cognitive load on the model as well. So that's why I really like trying to ferret out the fundamental problem behind all of this, because then the engineering kind of just like falls into place, right? And so actually, maybe I should just like I'm just gonna say add tasks to the ticket, build them one by one, commit as you go, query, so that we get. I have to stop at 2, so that we get like a finished version of it, even if I haven't. I'm gonna trust GPT-5.4 enough here. In fact, the simple fact that it did write it like this, and I have done the reading of the scientific papers, and I'm like, oh, good, you were able to extract the core concept of what I was telling you out of a huge ass react keywords of mine. I can probably trust the plan after that, and there's probably just like a couple of things to review. That's why I really like these kind of like current state analysis, problem statement kind of things, which I think it has been very strongly reinforced to, because those are not words coming from. Actually, are they words coming from a skill? Maybe I should publish my skills, huh? Let's see. Is this something that comes from me? Gap analysis. Ha! Okay. Okay. So this is actually a good skill. Oh, holy crap. I had no idea. I was like, these documents are great. They're not too verbose and stuff. Use this style for the primary diasis tone. I mean, maybe. Oh. Oh, I had no idea. I thought it was like the training. Oh my God, they understand what they should be training for. I mean, obviously the models know how to do this, but then you need to be able to fetch these fairly. Once you see them, you're like, oh, it's almost too simple. But you need to tell the model to be like, look for simplicity, and simplicity of this really hard apparent problem by reading theory and by doing engineering. It's really fulfilling to me to be like, I have to read papers all day, or like look at history, study algorithms, really dig into bigger code bases to figure out what is the kernel here that I can tell an LLM so that it expands it to the whole code base, right? And in a way, I don't know if this is right. Like there's this whole thing with like Cardet where people are saying, is it a clean room rewrite? Can you change the license? If I plan with this stuff here and then I say, well, I got Kubernetes at the other end, how much of it is Kubernetes versus it's a new system because this will probably do the same stuff as Kubernetes, and I can probably slap a compatible API in front, but I could do the backend completely differently, right? And so the question is the fact that Kubernetes says that in their README something they should copyright, but they can't because they also just like got it from somewhere else? Like, where is the real engineering suddenly that is like worth doing, right? And like maybe the LLMs will understand that you can reduce it down to this simplicity of it. For this case, it has been written about. I don't think through the nature of even the kind of like genetic um, innovation that can be done when you have a pattern matching technology to do real creativity, right? To recombine things um, uh, to do something novel. I should stop looking at my computer. Jesus Christ. Um, so what is it doing here? So it's writing this. So we can start looking. It's like writing the domain. Okay. It's running. It's looking at a context. It's starting the HTTP server. It's starting. That's all HTTP. So we're in boring land still. This thing has a task list. So let me go here. We're code Vazen Friday the 13th. I'm gonna just oh, I think it's called API serve to revive this. It's been a minute. Because the same like manager thing, I tried many ideas with it. It can do all kinds of like reverse lookup stuff. I can like start looking at main.go, see that it's been mentioned here, right? In the diary, it's like, so this is the diary that the model is currently writing, and it's linking all its files, which is really interesting. It's like if I open the document, you can see all the related files that it added to the diary. So amongst others, the one that it created, right? Those are all ideas I was playing with. The model doesn't really use them because I didn't build it the right way. So, you know, I've been using this for every task for like 4 or 5 months now. It's like indispensable to me. Test the MVP, commit each implementation. What? That's a weird task, dude. No. So they're like absolutely horrid. But I've been playing it for quite a bit now, and I think it's kind of like a novel concept in itself to be doing, especially this like metadata. I mean, it's not new, but also testing it with LLMs is something that's fairly new, especially this like linking of documents with making. So people are talking about semantic graphs, and I even have like a graph thing that's broken. um, uh, but I think like all of this, maybe it's not, but the fact that you can do it with like 3 lines of code is pretty nifty, right? And then because what it allows it to do is when it reads this guide or like some documentation, all the source files are going to be linked to it. The model will immediately find them. It doesn't need to search the code base. It will know when things are irrelevant. It will know that if there's a bug, it will find immediately the ticket and the documentation for it. Like those are things I've been testing. They work really well. In fact, the metadata to a document that's correctly named is usually enough to, it will read, like I can see it read like the first 100 lines of a document and then go straight to the right resources because those are at the front, right? It will update them as it does, for example, bug reports. It will link all of these guys here, and then you can kind of look at it. So a bunch of things to go back to in terms of like conceptual thinking, right? Um, so Codex, I have it on high. I don't know if I think this is a task for Medium that works well. I don't know. I have to play more with GPT now that I'm getting into token count issues. This may be a time for me to be a little bit more careful and clever about my prompting. The problem is to do prompting explorations. That's when I have a ton of tokens until I figure out what's really efficient. So anyway, I'm gonna have to wrap up. I hope we have 10 minutes. I hope that I get to a working version of the demo. Let's go look a little bit more at this because it actually already has the code in it, most of it. So this is just like a dense version of actually what Kubernetes does. And you can see the reconcile loop. It's going to be fetch the real world, right? Compare the real world to the desired world. Literally the steps of the algorithm before. Then it's going to compute a plan, right? Like this, suddenly this is starting to get muddier, right? Because this is only called act, and the context of the concept of a plan has disappeared. Really important to note, right? The word planning has completely disappeared. I trust GPT-5.4 to kind of recreate the concept of planning later on, but I'm not fully sure. And so the fact that plan disappeared removes a lot of power from this code because, and I could accelerate this. One of the patterns that I do now is like, well, if you go back to these guys, right? Actually, we can use Claude to do it. If you go back to, where's my loop? First explain the fundamental of the 60s, loop forever. Where was this really crisp definition? Did I close it? No, this is the really crisp definition. So we're going to go back here. We're going to make a new Claude demo. And however, what we're going to do, dude, where can I create a new chat? Why is this so bad? So I'm going to paste this in here. I want to be able to use snippets for observe, build, compare, plan, execute to test out different scenarios, use eval, make a set of presets so I can choose different scenarios, add editor on the left, simulation on the right. So if you take this abstraction, like the purest distillation of what Kubernetes, for example, does, and then you say, well, if you replace these with something that's scriptable, then suddenly plan is really just something that takes a diff and computes actions. It's like this purest form of planning there is, right? Is like it gets an input and then it outputs a list of actions. That's my planning. And then I execute these actions, which is also very simple. I get a list of each actions. I'm going to execute the action. Same thing for observe world. It's very simple. I'm going to use my sensors. I'm going to read whatever sensors is, right? And then that's my world observation. And comparing the world to the desired world, also fairly simple. I walk down, like the observation is like a graph. I will walk the graph and I will see like, well, there's a node missing here. There's a node here. Also very, very simple, right? And so suddenly all of these little functions are very simple. In our case, observe world is like counting the number of running comparing, well, I want 3, you want 5, it's one line of code. Planning is like, well, if there's like not enough, then I'm going to create 2. And then if there's too many, I'm going to kill 2. Then I'm going to execute the action, create 2. I'm going to be like, okay, well, 1. And that's it. It's like even less code than when you write it out. And then, however, it applies to every scenario. Like now, if you want to like paint your walls blue, you could say observe the world, the wall's green. I'm gonna say compare. It's like, well, it's green, not blue. So painted blue, then you paint it blue, and then you have the Kubernetes loop is suddenly like something you can use to plan your world. Man, this looks like ass. Where are even my presets? Oh, so this is web server scaling, right? So pretty cool. Observe, actual, there's like replicas, there's all of this. Then the comparison is like, that's kind of desired state is here. Wait, can I switch that? Desired state, replicas 3. And then executing, right? Like the planning is pretty simple. If there's replicas, then you say like scale the replica up. If the image is different, if the hot CPU is this. So it's already like fairly complex. But now I've got, you know, something that can like scale web servers. And now it's in sync, and obviously I can't like interact with the world. But I can choose like maybe some more, make up some funkier scenarios and allow me to interact with the world object, desired world. Using a little UI DSL. Store UI in the preset 2. Create new file, because for some reason Claude like has trouble overwriting its own files, or used to. So you can see now, however, the same algorithm and 4 little snippets of code are enough to apply this to a shit ton of stuff, right? Here, I'm sad that it didn't do like a wild set of things. Oh, I can edit the desired state spec. Okay. So I hope that it's going to do something a little bit more interesting. Space station life support. Yeah. So you can see the model knows like, yeah, I can use this for like a shit ton of stuff, right? And because I boiled it down, like I'm barely prompting anything. I'm prompting this, and then this is generic, right? And here I'm just saying like, you know, these functions, like make them JavaScript snippets that I can manipulate. So I've broken down the entire complexity of this. And if you look at, you know, at this code, observe, plan, execute, if you find them in the Go, you're probably going to code compare, like, right? Like this is already like so much code in here. Obviously there's the UI, but if we go back to this, to the Go, right? Like there's a lot of stuff in here. And obviously some of this is like necessary to do like distributed stuff, like communicating over channels. But it muddies the water significantly, right? Like suddenly this like elegant little tiny loop in the middle is gone because it started to index too much on this like menial stuff. If, however, you're able to keep the tight core to, and you have to be pretty careful because models want to explode it. They're going to explode it, and as soon as it's exploded, it's going to more, and so your whole application suddenly is going to become a morass of complexity because this pure little idea suddenly is like not apparent anymore, and so it's hard for the model to say like, hey, you know, the reconcile loop is here, but it's very hard to figure out that this is planning, right? But if I have plan.js and I have Go, it cannot mix them. So this separation stays very clean. And I don't think I can get there. Well, like, fuck it. We're going to get there in this stream. Because this is really like core of what I'm playing with and like how I'm able to increasingly get like crazy stuff going. Because you would say like, hey, what are you, the fuck are you doing here? Like, you're building a demo of Kubernetes and React. Like, what is this? But then once I have, say, the JavaScript things, and then I give the JavaScript access to spawning databases. Like maybe we could do that. I'm trying to think of a good example. That's why I asked it for the funky stuff. Let's go to the funky stuff. So canary deployment. Oh, we're still writing. Salsa making. Like all of this stuff. I don't know what it's doing here. Like, fingers crossed. This is the kind of stuff it's the first time I try this level of complexity inside Claude AI. But also, if you look at the code, you're probably going to find that reconcile loop very easily. And you can see this is completely generic, right? Like, so this is data. These are the presets. All right. Well, I knew this would happen. And I knew this would fail. Or does it fail? I saw like an error message pop up. Yeah. I don't think this is salvageable. I think I asked too much. But we can still look at the code. So you'll see the loop, the core loop is still here. Like you have all this crazy stuff, space station, blah, 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 blah. But then if you look at, where's the core loop? Come on, editor, tab, load preset, run one tick. Core loop. It's just, it's being ticked, right? Actual new function, state, observe. So it's calling observe, right? It's doing eval observe. It's doing eval diff. It's doing eval actions. And then it's executing the action. So the core loop is, besides the logging, is here in its purest, and it's going to be really hard for it to fuck it up if it has to get all these functions from a data object, right? Suddenly it'd be like, well, I have a data object. It doesn't know that it's code actually. And so the separation of all of this is amazing because the planning cannot do anything. The only thing the planning can do is like fucking compute JSON. And the only thing that can do things is execute. And you can very carefully sandbox execute to say like, yeah, you can only like paint walls, you know, you cannot fuck up my database because you don't even know that the database exists. Like you have no way of, here obviously you have eval, so this is just a prototype, but all right, let's see. Space station life support, zombie perimeter defense. And you're like, see, and I invented even like this thing here. So now we can really start playing. Press run or stay in. So I wonder, yeah, there's gonna be this was too much. I knew that this was gonna be too much. Especially with this amount of JavaScript, I think it's just using const. Yeah, I knew that const is always an issue with JavaScript eval. So I do actually have an AST parser that replaces const with let before letting it loose in the JavaScript VM, because this is like the usual problem that it runs into. But I hope you get the idea of like how powerful boiling something down to its abstraction is, and maybe we can get there in this here. All right, so this, I knew this was gonna run into sandbox stuff, even with their new stuff here. So two, unable to connect because it killed it. What did I do? All right, anyway, so we're here. Apparently it seems to be running UI. I'm gonna say pnpm dev. Yeah. All right, so then I'm gonna run the go run command pod demo listening 3001. Oh, it's still starting it. Proxy the Vite. I don't know if the Vite is actually proxied. That's one of the things that it loves to do. Am I really at 0% battery? No. Vite, oh yeah, it proxies it. Nice. So there's a chance. The fuck? Oh, I killed it. I'm such an idiot. All right, so we have our thing here, and then JSON parsed because the server has been killed. I finished the live verification, like literally the second it kills the server. I love it. Where am I at? All right, is this running now? Yeah. So this should now be real Go workers, and there's like 3 workers, and then yeah, see how fucking fast that is. So now it's nice that we have this thing here. Where is it? The Claude thing. This guy here? Yeah. Because now I can go to the source code. I can go here, and then I can say, um, you know, you'll reconcile loop with pluggable JS patterns, allow respawn launching with different presets, directories with JS files. I hope I'm talking. I shouldn't do that. I'm going to finish this guy just for the sake of it, and then I'll have to go. Create a new ticket, use. And I'm going to use exactly the same technique than before. Yeah, I really have to be careful when I talk. I do this kind of stuff really bad. Let's see what it does. It's GPT-5.4 high. This is not good. There's a lot missing here, I think, that I would need to clarify in my head. But it's GPT-5.4, and we will get to read it. So let's go. But I hope that this. I mean, on stream, so I can turn this into an article, seeing the things this way, and then using just filling in the exact amount needed for just a certain thing, right? Like if you look at compare, this is going to be, man, this looks like ass. Usually it does syntax highlighting, whatever. You can see this is very zombie code, so that when you're in the domain of zombies, right, and you say like, well, I think if the desired turrets are not enough, we should like actually order twice as much, which is something you would. It knows exactly where to modify the code. It's like inside here, it will say, hey, if we have more than 3 turrets, then this. So the fact of using something like JavaScript plus a VM that only exposes a single data structure turns the JavaScript into a powerful domain language, right? By virtue of having, and because JavaScript has been written for humans, has been invented for us humans to talk about these things, it's actually pretty readable if you keep it clear. And then all the added complexity that we usually have is because we're losing track of the abstraction that underlies all of this, right? But when you like break it down, it's almost like the emperor's new clothes, where you're like, yeah, of course I observe the world, and then I see what's not right in the world, and then I do a plan, and then I execute the plan. Like, yeah, of course. What are you talking about? Um, but actually, that's all you need, right? All the rest that we say, like this is complicated software development, blah blah blah. That's actually not true. It's just because we lose the plot over time. And then once it gets really, really calcified, or because finding the plot is really hard, complex software starts to exist, right? And this is not new. Like I didn't discover this. This is like if you read SICP or if you read like Alan Kay's Smalltalker, um, this is nothing new, right? Is that simple code is enough, and then some things are really hard, like computing this so that this is really really fast on the GPU. Like mine sucks. Or the fact that I'm streaming to you, there's like a shit ton of data that has to be copied really really fast. Like that stuff is hard at a lot of layers of the stack, but due to physical constraints, right? Partly also due to algorithm. You can't like just go over every pixel with a CPU because it's not a good algorithm. So certain of these, you do need to put effort into them. Uh, but you also need to put effort into how to compose them. What 99% of software engineering is in the real world is composing systems, right? Like um, no one's going to invent like a, I don't know, electrified fence every day. Well, just going to say like, yeah, we can turn it on and off. And I'm a little bit annoyed about this const thing. I should have, I should have noticed that, and I obviously can't edit here, huh? This is something they should do. Um, all right, where's our JavaScript? Where's our Go at? I'm writing the main analysis document. I will be explicit from new function to a Go-owned reconcile loop using scenario code in Goja with preset directories, VM restart semantics, JS primitive. See, sometimes it's good that it adds words. Restart semantics is, I said restart, I didn't say semantics. So it's a good word to use. It's a little bit generic. And then I've seen it like add these things a little bit willy-nilly. API contracts is another one that's contracts is not something I've mentioned. Maybe it's in the skill though. Let me see. I mean, maybe I'm just like, maybe all of these words are in the skill that I generated and never looked at. Actually, let me look. Contracts. Yeah, it is in there. Is semantics in there? Goja module. But also it's like this is like a GPT-ish words, right? Guidance. Oh man, this is where it's coming from. Where was the one from yesterday? Controller. Dude, this is where it's coming from. Oh man. Oh man, this is why it shows runtime controller. Holy fuck. Oh, I should have thought about that. That's why it's adding runtime controllers to everything. Jesus Christ. End time. Uh, oh man. Should I remove them? They're both good and bad. Oh, I hate this shit. This is hard. This is hard prompt engineering. Should I remove these or not? The runtime controller especially bugs me. I was doing design and it added like runtime controllers everywhere. I'm gonna add, this needs to be verbed out. I'm gonna extensibility. Is that a word even? I don't know what entry points is anyway. Map to the best idiomatic concepts. I think this might help. I like this. Current behavior, gaps, risks, and constraints. That's what we saw, right? Then does it say runtime some? I think that's where it was fucking coming from. I hate it. To add something that weakens this, think about things like, and then I'm gonna state expansibility. All right, so this hopefully will steer it away a little bit. To the best, to the most, to appropriate. I'm weakening the steering here a little bit. So this is good. Contracts was another one, huh? Like you've seen the effect that these words have, right? Like it said API contract in the middle of something. I was like, yeah, that's a weird word. Inspect existing for all right. Oh man, why didn't I think of this? I should read my skills much more carefully. Like notice, because Claude kind of fucking ignores them, but GPT-5 really locks in. All right, so it created that document, right? And so what I would do now is obviously, I mean, not obviously, but to me, because I do this so much, is go back and see inside and blah, blah, blah. So now we have pod deployment, Goja reconcile. We have our new little document. This is 20 pages. Jesus. I'm going to trust it just so that we go ahead, tasks, commit, diary, etc. Up, because it knows it from the previous pass, and I think the compaction must have caught it, and it probably will catch the skill. And so then this is where I'm having fun, learn stuff. I do my prompt engineering. Well, that's why I'm like noticing these words so much, is that right? Like those are words I used in the prompt. These are words that I should really cross check every word that sticks out to me with the skills. Right, because this word state here is important. That's why I reduced it down from like state slice, which comes from Redux, to state. Because slice gets too much. It's a if you wonder why I'm so aggressive about words used and stuff like that, this comes from small models, right? Where you would say a word and I would be using that word. And these models still are the same at the core, right? They have been trained on next token prediction. If you use a certain token, it's fairly common that you reuse it later on. Like, you know, if you use English words, then you're going to use English words. So if you use the present tense, you're going to use the present tense. If you mention something like state slice, the next time you talk about state, you're probably going to add slice to it, right? So, however, when you see state slice and you say like, well, I've got to do JavaScript, then it's going to be like, oh, Redux, just because it repeated the word slice in a place where I didn't want it to repeat slice. So, or on the contrary, I say state slice because I'm like, the moment I put state slice together with JavaScript, it's going to be, oh, that's Redux. Or it's like another reducer pattern that uses the slice word. So finding words that are powerful, precise at times, like this stuff is hard to find words that are maybe too precise for what I want to use them for, as seen here. Runtime controller really fucked me yesterday. And I was like, why the fuck does it keep adding the word runtime to everything that I'm doing? Is like, I don't care. So now I weakened it by saying runtime behavior, which is a much more used way of talking about what I'm interested in, which is the behavior at runtime. It's not like a Java VM runtime, right? Which is what it was trying to sneak into my design yesterday, for better or for worse. On the other hand, it does interesting stuff, right? So that's why I would recommend doing like exactly what I was showing here, right? It's like you can go just experiment. And then often turning off the thinking is interesting. Kubernetes design, but as a stack threaded fourth runtime. So you can just put random words together and then just see what comes out, right? And so here you can see smaller model brain, but I really recommend doing this with really, I mean, I don't know if GLM 47 is like smaller. It's definitely fast. And then not care too much about the result because it's like nonsensical. It's more like about, hey, what things is it going to fetch? What concept is this word going to fetch? And so you can see here, like stack threaded fourth runtime, it actually decomposed my phrase into exactly that. It's like, oh, fourth runtime fetches, right? And then you can see how these concepts are going to be slowly like diluted and transformed. Right? So suddenly it's going to be like, hey, there's like etcd is the backing store, but in a stack machine analogy, stack is the current context of the node cluster. Like, this is like looking at tea leaves. Obviously, none of this really means something. It's just like the LLM taking these words and like stringing them together. And with small models or smaller models, it becomes really, really evident what it is, right? Here, because it does all this yapping, it's like kind of doing a remake of all your stuff before even like putting it out. If you have straight models, so let's see if we have something really fucking bad. What do we have? Quality 2. Mistral small. So here you can really see it like matches the words one stack threaded fourth runtime, right? Like here it doesn't even decompose that further. It says like, oh, there's a comma. I'm going to analyze the two, and then I'm going to just like do some minimal remakes. That's like not all that interesting, but this is still interesting, right? You can tell here it's just like mixing the words up and like kind of doing like some menial thing out of it. If you go now to here, you can tell the difference that it makes, that it like from the web and like thinks longer and all of that stuff, right? So what's interesting here is that because now I told it to do this generic approach, it probably refactored the loop that was getting messier and messier as we iterated on it, even already just once, right? To the reconcile loop, where suddenly the reconcile loop is back. This didn't exist before, right? It was gone. It was just like weird thing that had like a lot of worker code and stuff. So here we maybe bullshit. Maybe it was still here. Yeah. So sorry, it hasn't rewritten it yet. So this is the man. GPT-5.4 is good. I hate it that it's so good, and I love it that it's so good. Man, this thing is like, I look at this, I'm like, there's no way that this all is like good. Look at it, I'm like, you motherfucker. You motherfucker. You put like interfaces. Like sometimes it over engineers things a little bit, but you're like, oh, dude. Like, how? Oh man, this is a pattern that I didn't know, for example. See, I learned something every day with this guy. I mean, I must have known there before, but I rarely use it. It's been a long time since I wrote, and I see all these files. And I'm like, there's no way that the event hub good. And then I look at it. I'm like, God damn it! You do like bounded buffer channels, which was like often a thing. You have a semaphore. You have a semaphore? Yeah. It's like, man, you are good. And it shows like a real understanding at some point. Like this could still be like, chain inference, like pattern matching stuff. At some point it comes up with a pattern. I'm like, you did the abstraction step from something really shitty that I gave you. You were like, oh, I think it's this abstraction. So that have in terms of reinforcement learning for the software side, I think they have uh, at least this kind of like abstracting away from it for a bunch of technologies baked in. Um, I don't know how they do it. I should read. I don't have time to read that many papers. Um, where are we in the tasks? So I must say I have this UI and I don't like it, so I don't. I barely like. I usually look at this. And the task list, it's not all that good. I do have to tell it to do like a detailed task list for an intern, and then it breaks it down. On the other hand, it has its own codex planning thing under the hood. There's a lot that I'm not seeing. Um, but I like having them explicit because it allows me to switch from model to model more easily. Because whatever is good for 5.4 high might not for medium. And I'm going to have to start thinking about token count. So, this is going to take like 10 more minutes. I need to go pee. But I think I got a lot of yapping that I wanted to clear my head out on stream, which is the main reason I'm doing these, because no one's watching, obviously. But I've figured that someone's watching, so that's good. All right, I'm gonna go. All right, is this stuck? I hope it wasn't stuck. I've had it being stuck quite a while. When I came back and it was like 1 hour and 30 minutes. Uh-uh-uh. I'm the fuck. Um, man, I really don't know if it's working or not. It was like I don't know if it's emitting like thinking tokens that I don't see, and the censoring is catching up. I'm gonna. I don't know if this even helps. Uh, um, let's see. I wish this was like a little bit clearer, to be honest. Yeah, it was stuck. All right. Man, I'm getting hungry too. See, annoying being on stream and not having anything to yap about anymore. Uh, Usually I would just go for a walk now, but I really want to capture that as it's happening and narrating it because I probably catch some interesting stuff. Um, and I don't think I can give it to Claude at this point. Should I try? Claude's going to do some fun. Maybe that's going to be interesting to have on stream as well. Yes, I trust this folder. Work on doc manager ticket. What was it called? Goja reconcile 001. Read the skills because this one always forgets the skills. Check off task byte. Commit as you go. Keep a diary. Continue our colleagues' work. Make sure to read the previous diary and the design doc. Come on, let's put the turbo. I'm sure it's gonna start fucking shit up. I really just use it for UI. Then I end up with all these like 800 lines files. It does this nonsense. I know I should learn the tool, but I'm like, man, just give me like a raw agent that's like what I like doing. I should use Pi more. I mean that it's going to cancel my subscription now. Um, but we'll see. Um, all right. Yeah, no one wants to look at someone waiting for Codex, huh? Um, so it's exploring. That's interesting. All right, 40,000 tokens. I think I'll probably be at like 80,000 before even starting. Um, which is not the worst thing. I guess I should use plan mode. I don't know. I don't know how it all interacts. I know how raw models kind of behave ish. Codex harness is pretty minimal. I really need to build my own. $50 tool uses 60 tokens, 60,000. That's not too far off with my 80,000, I guess. Is it Acme Corp staging? What the fuck? Yeah, what the fuck? Good. See, it already starts. Acme Corp staging 1. The fuck? Oh, so the scenario's already there. That's nice. Yeah. So, because what's nice now, right, is space station. That's like where in my real life most of the work would be done. This is where you communicate with your customers, with your users, and you say like, well, we want to have like a heat phase and whatever, and you're like in this completely isolated, almost trivial kind of environment, right? So, and the cool thing you can see, like this is purely functional, right? Data in, data out, doesn't do anything, cannot do anything, cannot write to the database, cannot like literally don't not do anything, purely functional. You can run it in a simulator all day long. You can run scenario testings on it. You can do fuzz testing. It's going to be like extraordinarily fast. You get a full trace of whatever it's by the virtue of simplifying all of. See, it's adding all of this garbage. Maybe I'm being a little bit too harsh. Compile phase primitives. Yeah, not bad. We'll see how this goes. I mean, I shouldn't talk too much shit about Opus, but why did it add this, the session thing? Yeah, I think this is already. So, can you tell the difference between how much is in here versus the codec stuff? This is also Opus, huh? No, 50 minutes ago, this was still codecs. But you can definitely see, even for something that's as formatted as Go, you can kind of start seeing. I think that Codex, for example, would have extracted these guys out to a separate file, because now you have these like host primitives, but mixed with like call phase. Call phase 2 is like all. I don't know. Maybe I'm just like wanting to yap on it a little bit too much, but um, all right. Anyway, yeah, you see it starting. It's like this stuff means it didn't understand it from the get-go, right? Like it just means it was doing like, and maybe Codex doesn't understand. I mean, obviously it doesn't understand it. It's like doing thinking beforehand, but that makes a difference because like these like returns is adding not only more tokens, but it's adding more confusion and options for Claude to start lying. All right, please let it happen. And this is definitely not the stuff I would Claude usually. See, we already had an HTTP thing, so now it's just piling shit on. It's like basically duplicating the whole server thing. While I'm pretty sure Codex would have reused and anyway, this is just like a demo for the stream, but and it's if you catch it early, GPT-5 4 does a really good job at just cleaning things up pretty nicely. Uh, but the thing that Claude is going to do nicely is like make a killer fucking UI. Why is it deleting all of that? At the diff of my reformatter. It's funny that I found out that's an ID reformatter. Oh, I shouldn't have allowed git checkout. What the fuck? I hate this permission thing as well. I think it's like a really anti-pattern. Anti-pattern due to the TUI as well. This time it didn't ask for committing. So funny. See, like the cryptic codex tasks, if he had broken it down more, it would have said like, oh, update the routes in the HTTP handler. Pretty sure it would have done that. I need to do more of these A/B experiments again. It's been a while since I did that. I should do more small model stuff as well. For a second, income. Oh, man, I'm hungry. I'm hungry and I'm out of food because I've been programming too much. Keep ragging on people that they're unhealthy with AI, and then the last few days I've like not done well. Not done well, although it's like not due to the AI, it's due to life circumstances. But all right, yeah, I know it's going to do a killer design though. I really enjoy the Opus UI designs. All right, we're in the final run. Cool. Let's hope. Let's hope we get something in the final rush. Generic scenario workbench. The existing UI has a deep space observatory aesthetic into a mission control console feel. NASA flight control meets modern DAW. The memorable element, their design document. The memorable element. I should do more reading of skill. It's been a while since I did like actual prompt engineering. Uh, I should do that more. Like maybe that will. This runtime controller shit. I can't believe it that I didn't think of looking at the skill. All right. Oh, see, it's got to start updating the port because it didn't figure out that it's still running. Like, please don't update the ports. It's this one and this one. This is the stuff that, like, I find horrible. I mean, I'm gonna let it do its thing because I don't want to fuck even more with it. But maybe it's just like, man, I don't know. Oh, what is it doing? I mean, I'm sure this works. I don't think there's a opus. Once models figure out in which directory they are, we'll have like real AGI. Once they know how to run processes in the background as well. See, what the fuck? You started it. You modified the port and what the fuck, dude? Insane. Man, I can't believe it. I'm gonna I have to do something about that every fucking time. Every fucking time. Yeah, see, it's not working. I knew it. I shouldn't do this. And all right. Hey, Crassy, when I'm gonna log off pretty soon. I think I knew Claude would fuck shit up. I just knew it. I knew that it's too much. Um. Anyway, let's move this to a desktop where it has room. Uh, So that means I can start fucking with it too, huh? I shouldn't, I guess. Fuck is that? Uh, I don't think the backend works in this thing. I shouldn't have delegated this to Claude and get it. I'll have Codex do a pass. I think at this point, this guy has like no fucking clue what it's doing. Yeah, because you killed the server. You um, proof once again that either I don't know how to drive Claude, which is certainly possible, or it doesn't know what it's doing. So let me do a resume here. Uh, I sadly gave this task to your colleague, which has done some big fuck shit on the back end. Have a look, analyze it, create a detailed document on Goja reconcile on still for the intern upload to Remarkable. The UI is pretty nice, but there might be connection fundamental issues. The design is good. All right. Um, let's see if it figures that out. I knew Opus wouldn't get it. Opus, you have to give it like much more granular tasks or let it do its planning, which I guess is like the same thing. Um, the simple fact that it duplicated the server is to me a big what the fuck. Oh, so there's pod demo and there's scenario demo. See the simple fact that it did that. Interesting though. Yeah, I need to do more A/B test stuff. Um, or I mean, I'm getting by fine with GPT-5.4 High, but it's good to explore what is out there and not like be too codex pilled. Uh, so what I would do in real life normally is like just like read a paper. See, this guy is fucking good. I'm really curious to see because I'm 99% sure that it will like do bug report analysis. Um, I've confirmed the race detector is clean. I've isolated the main integration fault lines. Please tell me what they are. I want to see your thinking process. That's one of my main. I hope we get. I mean, everything's an indication in like 18 months. We'll have something that's like maybe close to this in open source. I think that's around what we're lagging behind ish, usually. But already the small models are just like interesting enough to get stuff done. It's just like not. Tell me what the bug is. Please. Please. This censoring is like really annoying. I hate OpenAI as well. For the good of humanity, we're doing open AI. All right. Holy shit, I like barfed it out all at once. The current state of Goja is not a failed design. It's a partially successful redesign with an integration split. The new scenario runtime is real, testable, and concept UI. An intern should understand the situation. Blah, blah, blah. But the nice UI is wired to the second app in vDeploy, but the repo still serves embedded assets and still has the old app as its default server entry point. Like, yeah, see the split brain thing. I'm sure Codex wouldn't have done that, or at least would have done it differently, and it would have started with the entry point split. The nice UI is not the embedded UI. That's another one. Yeah, it's like this is, it's like someone rushing into it. This was always like Claude Anthropic's problem. Uh, I don't know if we can fix it. This is not good prompting. This is me just trying to get something going. Yeah, spec and speed updates do not publish authoritative snapshot updates, so the UI has to patch local state and clients can drift. This is, yeah, this is like kryptonite, right? Um, uh, I don't know how long I should be pursuing this because on stream, shouldn't have used Anthropic. Right, time to call it. I'm. We'll look at this. We'll look at this next time. Anyway, the design part of it, which I wanted to capture, is on here. Like this is just at this point, I'm not doing good work. I should have, I should have taken that walk. I knew Anthropic was in the back end. If I really wanted to have used Claude, I would have done this granular stuff, right? Like I would have given it this, and I would have given it pseudocode and file names, which at this point GPT-5.4 already knew, right? When it creates that first document, usually it already knows the end result. And so I was hoping that Claude would read that in this design document, right? This guy here, because this, I'm pretty sure, does have a desired output. So it had that. Okay, so this was created. See, it has all of this, right? And still it didn't manage to get it right. Despite all of this. And it still has runtime. Dude, this runtime word, I need to kill it. Or maybe I should split it into runtime or like behavior at runtime. Maybe that's a better way to phrase it. Man, this had like a shit ton of document. It even had like, oh, see, that's why it didn't delete the other one. Yeah, this is very interesting. I need to do more fundamental prompting stuff. Very interesting. So these are great to read, right? Like it's not like when these things happen, I'm a bit frustrated because I'm on stream, but actually when those things happen in real life, I'm like pretty happy because this is when I'm going to learn the code base, right? Like even if I do a code review of something that is working, I won't learn very much because everything's working. So I won't see where the friction points are. Here I get a good sense of like, oh, this is friction for this model. This is how the runtime actually works. Like this, I don't understand the runtime and how it hangs together. These are the moments where I'll be looking at the weird stuff, right? And so obviously for certain models, you need to do it more often. For other models, like 5.4, I usually stay at I stay level because I kind of trust this stuff. I'm like, yeah, I mean, if it works in behavior and the code looks like this, then like I don't really have to review very much. So Claude stuff, huh? This is Claude stuff. Yeah, you can tell. It just does way too much, man. Yeah, the deep copy map. I mean, the deep copy map is probably not that bad, but I knew it. I knew it just from looking at this first file that it wrote that it was not going to go well. It's funny how I wonder how I can tell so quickly. Where I was just like, okay, this is not going to go good. This has way too many things in here. Just by looking at scrolling at the file, I can quickly I see these structs and I'm like, I see the deep copy map. I'm like, this is cargo cult programming. This is cargo cult programming because it is already coming in as JSON, you know. It doesn't need to do this. It comes from the VM, from the JavaScript VM. It doesn't need to do it. Why does it store it in the state anyway? I guess maybe it needs to show it. I don't know. It's really interesting. I should rewind it and see what the clean from the start design is compared to the Codex version. Actually, maybe it'll actually fit in time. Where are we at? Collapse the default onto the scenario instead of the legacy pod demo. aligns the development and canonical ARP target. Keep command scenario demo as a thin alias or remove its. See, it's like removing all the legacy stuff. There's a chance that it might like go fast. We'll see. See, this costs time, and not only does it cost time, like rewinding would have, even now, probably rewinding is cheaper um, because the code quality is significantly degraded, right? And see here, you can see what Claude does, where it has like a fucking 400 line main app main file, and then it has the second one, which is just like duplicated as well, which is like 1200 lines. It didn't do any effort of like modularizing this. It has like embedded CSS. Like it didn't, it's like it literally didn't care. It was like, oh, you want me to do this? Yeah, YOLO. And it just like put this stuff in. And this over time, this, especially at the speed of AI, this really costs, right? So like the design is great. I really like that. However, um, I'm going to do a pass with Codex. Now that the design is great, Codex will be really careful about not fucking the CSS up and stuff like that. So, right, like now it's going to update the React. But so now I need to clean up even just this guy here, right? Because like now Codex is like, well, maybe I'm not going to touch all of that. And then suddenly Codex code has snuck in. Because like decode JSON, maybe the other guy did it as well. What's the codex code? See, the codex code also has decode JSON. All right, my bad. It just like copy paste. But my bet is this is going to work here. The goal here is not cosmetic work. It's to make the new workbench consume the backend as the source of truth. Stop fetching active presets UI out of band. Did it work? Did it finish? Were we at the last task? I'm so impatient. It's not a good thing to be impatient. It like addiction loop. So we're at like regenerate. Okay, we're done. We are done. Let's try it. Scenario demo still has it. Is it running it somewhere? Who's running on port 3001? I'm gonna kill it. V running on. The fuck? So this should be running. Localhost 3001. I think it's still broken, huh? No. All right, so here you have it, like fully isolated kind of where what is the actual, the O2 target is like around 23. Is it too high? Have 123. Yeah, so this is now like a, like a standard control loop where if I want to have like 30%, it's going to do what? So it's overshooting. Anyway, these control loops, like, I mean, they would need to be tuned. This is not the architecture that I would this, but like the taco truck feed this, that's much more something these kind of control loops have to do, right? Trucks. Why do we only have dispatch truck is not being taken? And it's funny that dispatch truck, I mean, I don't know how this is implemented, right? But I hope you get the idea. We got somewhere, and now all the work would be, oh, dispatch truck is not working. Let's go have a look at dispatch truck, right? Where is this guy? So we would go to scenarios, space station, and then we go to plan. It's kind of unreadable. Type dispatch truck, right? Like if the truck counts that we have, then dispatch truck, and then execute. We'd go dispatch truck, set state, add truck true. I don't know what add truck says. Current trucks for each if action trucks includes D, reroute action truck, set state truck. So I don't think this makes much sense, right? Add truck. If get state add truck, then we add a new truck. Yeah, I'm not sure if the get state add truck is a command to add a truck. I don't sure this should go into observe, right? And this is a Claude thing. This is code that comes from Claude. So validate taco fleet and find bugs. Adding truck doesn't seem to work. So here again, I think at this point for this fundamental thing, right? Like here, I would put a lot of effort into the prompt engineering to generate these guys because you want it to be, because then you can iterate really, really quick. But also like, right, like there's not much code to understand here. So it's going to read all 4 files at once, right? It's not a lot of tokens. And then if the current fleet does dispatch a truck, but only as deferred state for the next observed tick, I'm proving that with a focused runtime test, blah, blah, blah. So now in the runtime test, you can see how it creates a new JavaScript session. Is it going to do that? Session step, new hub, preset. Yeah, so it's loading the preset, and it's executing a JavaScript engine and just like doing a single step. So this is like can fully be simulated like inline. Which makes it really interesting because like you can have the LLM generate one of these JavaScripts and basically run it in a test harness before even exposing it to the application, right? And so you get this like really, really fast feedback loop that you can hide for. How's it going, Parthon, whatever? Parthon, Kusa, array, blah. I'm good. I'm about to wrap it up because I think this found that like, hey, you shouldn't like add trucks in here. Like round trip host states, actual trucks come back from get state actual as go exported state, not as a clean JS array. So push never behaves like a C. So you have to be careful about these things. You want to make sure that your primitives that are exposed to the JavaScript are really, really fucking robust or prompted so that they're used robustly, right? The script is patched locally. You have to return a copy of the thing. And so I would probably transform this a little bit more, put it in the prompt, right? And so the cool thing is you can do hot reload because this is fully functional. I haven't added it here, but you could really do this in like a really powerful way. So hopefully now it's going to do add truck, and now we have 3 trucks, right? T1, T3, T, and then we can do hunger level 2.6, and we can see restocking, priority zone downtown. They're rerouting all to downtown. I can go to the beach, lunch rush mode. You can do all these kinds of simulation scenarios and basically store them as data and say, you know, at this time we go at this point, at this time we go at this point, make sure that we have some kind of optimization metric, and now you can do a full optimizing loop around the tacos algorithm without going crazy. It's just like a JavaScript file, right? So you can do really, really funny stuff where with a minimum of complexity in the code, you can go really, really far, especially with LLMs that know how to optimize things like this, especially if you give them a clean trace, right? So if I now set the hunger level to 0.8, then nothing more happens. Sometimes they'll do that. But you can see the stocks like disappearing. I could add graphs very easily. It's like so much you can do with this pattern that because the boundary is so strictly enforced, you keep models from destroying it. That's the idea that I was looking for. You have a really strong boundary, as for example, separating two programming languages. The model is not able to fuck your abstraction up. That's the main point for the article that I want to write, and then I'm gonna actually wrap it up. I'm sorry, the people who joined, like actually people seem to have clicked on this, but I'm gonna sadly wrap it up. But like Kubernetes reconcile loop in JavaScript with actually not much prompting. If you go from the beginning to the end, I probably prompted 3 sentences total that were related to the problem. I think I put what were the prompts, just to go back. The prompts that I used, actually we have them all in here. So we have 3 tickets. This is the wrong project. We have 3 tickets. We have 2 tickets actually, and we have a full diary. So I will have the entire in here. So prompt context. This was our first prompt. Import this file that we did in Claude. So in Claude we had one more prompt where we had the Kubernetes loop example. Where is it? There. So we had this in Claude, right? Just pasted in the loop. Then I said, hey, I want JS snippets to do it. Then I wasn't happy with the examples. So I said, like, make up some funkier scenarios. We got this, which sadly is not working because of the JavaScript, and wouldn't have been working. No, it would have worked actually, I think, with the push thing. But you can tell already the separation between the 2 domains wasn't clean here because it was the same language, right? And then we tried to fix it once, and then it was like, whatever. We imported this file into Codec. We read the document. Then the second prompt, I think, was the prompt context was like add task one, commit as you go, keep a diary. This is literally could be a button. And then I switched to Codex. So this is where stuff. This is where we broke shit. The same prompt, and then we moved on ticket, where we moved it to JavaScript. And so here, where's the diary? The diary for the JavaScript stuff, the prompt context was like, use a real reconcile loop with pluggable JS scenarios, blah, blah. So this is kind of the third prompt that has meat in it, right? Like the first one was in Claude. The second one was for the first ticket. The third one was for the third ticket. And then because I used fucking Claude Code, I had to put in one prompt of fixing. I sadly gave this task to your colleague, which did some big fuck shit on the back end. Have a look, analyze it, create a detailed document, upload it, and then keep the UI design. So 4 prompts to have this reconcile loop with JavaScript running. And so now, just to show you the power of this, is like create a zombie fleet scenario as well. So now we can create JavaScript very, very quickly. It's very, very easy to review it. And we can tweak the scenarios as much as we want. It won't mess up our Go because it doesn't even need to touch up the Go, right? It's literally self-contained. And it's going to be, hopefully it will show you that we're at 35% context window left. I imagine that like 31% it will be done. 30%. 30%? That's going. Come on. I should have turned it to medium. Yeah, because that's the other thing. Is like suddenly you can use small models, right? Like I could probably use Mini to do this. I should try with Mini. Boom. 33%. I think that's all it needed. Zombie fleet. Breach 14 zombies inside perimeter. And then unexpected end of oh, because it's like still editing it. Is it? Oh, that's interesting. What's the fuck is the JSON data? Error. Parse it on the WebSocket. Switching protocols. Why is it reconnecting? The fuck is that? Yeah. I'm gonna stop fucking with Codex until it's done. It knows better than me. So there's probably the WebSocket part is probably a little bit under designed. There's a lot of stuff now that we should clean up. Not only because of Cloud Code, but just because we've started adding things where the WebSocket stuff is something that I know from experience you need to tackle a clean WebSocket manager fairly soon, especially on the JavaScript side. Even with GPT 5.4. So you do need to guide the design a little bit there. I don't know if this is like a real issue. Yeah, see, it was just like some kind of building issue or something. So maybe not. Let's see. Yeah, there's something weird going on here. That's interesting. All right, I'm gonna stop here because otherwise I'll be here all day. Interesting. This is the WebSocket stuff. It's coming from Claude still, because I suspect it's coming from the front end side of it. Anyway, this was interesting, and see ya.